The Logasol chainsaw sawmill, used in conjunction with a steel chainsaw, is a portable machine dedicated to sawing solid wood into boards with high precision. Unlike traditional Alaskan saw systems, the Logasol is equipped with an extendable aluminum guide rail, which helps to fix the cutting line and ensure absolute straightness when operating by drilling both ends and fixing the slide. The saw is mounted on a sturdy slide, moving smoothly along the rail, allowing the user to precisely adjust the depth and thickness of each slice. This design not only improves safety when using, but also significantly improves work efficiency and product quality. With its lightweight, easy to disassemble and transport, the machine is suitable for carpenters, semi-professional woodworkers, and even loggers in the forest or remote areas. The complete sawmill line described here is a fully automated, high-performance system designed for maximum efficiency in log processing. It begins with the automatic log positioner, aligning logs precisely for the first cut LPRO using a 1 1/4 saw blade, capable of processing an average of 830 centimeters logs. The automatic log centering system ensures proper alignment for the MPRO block mill, also equipped with a 1 1/4 saw and automatic dog feed system for smooth block cutting. The process is supported by automatic feed control, which regulates material flow between stations, optimizing throughput and ensuring synchronized operation across the line. Next, the SFH with 6 MPRO heads provides high-speed, high-precision sawing. Boards are then sorted by the high-production automatic grater, capable of grading up to 48,000 boards per shift. The board unitizer stacks the boards efficiently, enabling automatic package removal for downstream handling. Following this, the mill edger performs automatic trimming with precision, while the SFH with 3 MPRO heads completes final cuts. The process concludes with the mill chipper 220 by 600, 100 hydrogen phosphide, delivering wood chips with an excellent granulometric standard. This integrated sawmill line guarantees high productivity, precise cuts, and optimal raw material utilization. It ensures minimal waste, enhanced operational safety, and reduced downtime. With automation and automatic feed control, it delivers cost efficiency and consistent quality, ideal for industrial-scale wood processing. This advanced sawmill system also includes centralized control interfaces for real-time monitoring, remote diagnostics, and energy-efficient operation. It's engineered for durability, scalability, and seamless integration into modern timber processing facilities. Cutting large tenons in green oak requires power, precision, and the right tools. In this case, a Hikoki C9 circular saw was used to make the initial deep, straight shoulder cuts in the dense green oak, taking advantage of its powerful 2000 W motor and 66 mm cutting depth. After measuring and marking, a Milwaukee H66 rear handle circular saw took over to remove excess and fine-tune the tenon. The machine's powerful 66 mm cutting capacity and high torque are ideal for working with wet, fibrous woods like green oak. The tenon is carefully shaped by making a series of parallel cuts. Finally, using a wood chisel, the excess is removed bit by bit and the frame is inserted for trial fit. This method ensures a tight, structural joint suitable for heavy timber frames or traditional joinery. The octagonal oak staircase for Duncraig Castle is a remarkable example of craftsmanship, precision, and problem-solving by Winder Joinery. Built entirely from solid American white oak, the staircase was designed to fit within an 8-sided stairwell in the historic Scottish estate, presenting both geometric and logistical challenges. The process began with technical CAD drawings and the creation of an exact OSB template of the ground floor on site. This template was carefully marked, dismantled, and brought to the workshop, where it was reconstructed to serve as the physical reference for layout and measurements. Each newel post in the staircase had to turn 45 degrees to follow the octagonal form. These posts were fabricated by laminating 4 oak segments, each cut at 22.5 degrees, then glued and clamped to form strong angular components. Due to the weight and size of these posts and the limited access within the castle, the posts were constructed in 2 sections, connected on site using half-lap joints. A unique aspect of the build was the reverse assembly method, starting from the top flight and working downward. This unconventional approach was required because assembling from the ground up would have made installing the final upper section nearly impossible. Throughout the process, strict compliance with building regulations was maintained, despite the staircase's intricate design and custom fit. The final result is an elegant, robust staircase that harmonizes with the castle's historic architecture while meeting modern standards. With a total height of 5.2 meters, the staircase not only showcases Winder Joinery's high-level technical skills, but also their ability to execute complex bespoke projects. Their work at Duncraig Castle continues a legacy of fine British joinery adapted to unique architectural contexts. The manufacturing process of a green oak truss, designed for a gable with double glazing, involves precision craftsmanship and traditional joinery techniques. The structure follows a king post truss design with queen posts, angled braces, and a horizontal tie beam spanning approximately 7.31 meters. Each timber element, such as the ridge beam, principal rafters, posts, and braces, is dimensioned precisely, often using 12x4 or 6x2 oak sections. Carefully selected green oak is used to ensure minimal warping and splitting. After rough cutting the timber, components are marked and cut to size, and traditional mortise and tenon joints are crafted. These are dry-fitted on a flat surface to check alignment and accuracy. Once confirmed, the joints are secured using oak pegs without adhesive, allowing the wood to season naturally. In some cases, hidden stainless steel screws may be added for extra structural integrity, especially where glass interfaces require additional support. Grooves or rebates for the glazing units are also machined at this stage. Finally, the completed truss is transported to the site, where it is carefully installed and prepared for double glazing. The entire process reflects a balance of tradition and modern performance requirements, Timber frame joinery is an essential skill for both beginners and seasoned craftsmen, with the mortise and tenon joint being one of the most fundamental techniques. This joint is known for its strength and simplicity, making it ideal for various woodworking projects. For beginners, mastering this joint requires practice, precision, and a few essential tools. To start, you'll need a square knife for scoring, a chisel, a sliding bevel square, and a mallet. A saw, such as a 16-inch Makita, is used to make accurate cuts, while a quarter-inch skill saw can handle finer adjustments. The mortise and tenon joint typically involves a 2-inch thick by 4-inch tenon, a common size for many timber frame applications. It's important to measure carefully and ensure the cuts are clean to ensure a secure fit. In a timber framing shop, efficiency is crucial, as you may need to cut numerous joints. Ensuring your tools are sharp and ready to use will speed up the process and increase accuracy. For instance, using a Makita saw for the initial cuts and following up with finer tools for detail work can make the task go smoothly. Practicing your technique and adjusting your approach as you go will improve your skill. Wood choices like Douglas fir are popular in timber framing because of their durability and workability. As you gain experience, you'll be able to create even more intricate and advanced joints. With time and attention to detail, beginner timber framers can progress to more complex projects, developing the skills needed for larger-scale constructions and structural integrity. The mill rule is a practical and precise alternative to traditional square rule layout, ideal for shops with access to modern tools. It starts by selecting the most square and flat corner of the timber as a reference. After inspecting for twist, damage, or debris, the first wide face is planed lightly, using a handheld planer like a Mafel or Makita. A chalk line helps establish a straight edge. If the timber is slightly out of square, custom shims are clipped onto the planer to control blade depth and remove more material from high spots. This ensures a perfectly square and straight edge. Depth adjustments and visual guides marked directly on the timber help maintain accuracy through tapering. Once two reference faces are squared and dimensioned, e.g., from 10 by 12 down to 9.5 x 11.5 inches, the timber can be flipped and finished to exact dimensions. The result: accurate, clean, joinery-ready timbers. At Pickles Timber Frames, we specialize in building quality, handcrafted timber frame homes using traditional joinery and precision craftsmanship. The process begins with planing the timber to achieve clean, square edges using the mill rule method. Next, we move to cleaning out the pockets, carefully refining mortises with a mallet and chisel. This is followed by test-fitting components to ensure a tight, precise assembly. We rely on mortise and tenon joinery, a time-honored technique that provides structural integrity and visual elegance. Once the joints are confirmed, we proceed with pegging, securing each connection using hand-driven wooden pegs. The final stage is flying in the trusses, where large structural members are lifted into place, completing the frame. Every step reflects our commitment to detail, durability, and tradition, bringing your timber frame vision to life with integrity and skill. The timber frame raising at Trout Run Hatchery began with the careful transportation of each handcrafted component from the shop to the job site. Every timber, planed, marked, and precisely cut using the mill rule method, was arranged in the order of assembly. Traditional mortise and tenon joinery defined the structure, demanding millimeter-level accuracy to ensure structural integrity and visual harmony. Prior to delivery, timbers had been through an extensive preparation phase in the workshop. Each beam was planed smooth to expose the grain, then marked with scribe lines for joints. Pockets for tenons were hand-chiseled clean, ensuring a snug, accurate fit. Where needed, curves and chamfers were added for strength and aesthetic. All components were test-fitted at least once, then labeled for efficient assembly on-site. On-site, crews began by assembling beam and post modules on the ground. Each joint was cleaned and inspected, and hardwood pegs were driven firmly with wooden mallets. The unmistakable thud of oak pegs seating into tight mortises confirmed the craftsmanship behind each connection, each strike validating the precision of prior measurements and cuts. The next phase involved raising the timber bench wall sections composed of vertical posts and horizontal beams. A crane lifted each bench skyward, while team members on the ground controlled the movement using taglines. Positioning was critical. Once vertical and in place, each section was secured with temporary bracing to hold the geometry until the next phase of the frame could be added. Then came the most dramatic and structurally significant step, flying in the trusses. These large triangular roof assemblies, often exceeding 30 feet in span, were attached to lifting slings at carefully calculated balance points. Suspended in the air, each truss was gently guided into position atop the erected walls. Mortises and tenons at the peak had to fit perfectly on first contact. There was no room for error, as these joints carried the weight of the entire roof system. Once seated, the trusses were pegged securely, echoing the same deliberate mallet rhythm. As more trusses were flown and set, the structure gained its full silhouette. Horizontal purlins were installed to tie the trusses together, followed by detailed alignment checks, plumb lines, levels, and braces, ensuring every part remained true. Throughout the process, no steel fasteners were used, only wooden pegs and the precision of centuries-old techniques. This raised frame was not just a skeleton of a future building, it was the visible expression of skilled labor, tradition, and trust in material and method. After the raising, final adjustments were made. Diagonal braces were tightened, and all joints were rechecked for flush alignment and stability. The team then prepared the structure for enclosure by marking service penetrations and confirming tolerances for insulation fit and wall paneling. By the end of the day, the timber skeleton stood proud, showcasing not only the natural beauty of the wood, but also the collaboration and accuracy of the team that raised it. The raising at Trout Run was more than a construction event. It was a ceremony of craftsmanship where history, engineering, and teamwork converged in the physical act of building. Critical stage in timber frame construction: the dry fit of a custom truss. Each timber element has been precisely cut, chamfered, and mortised prior to assembly. Carpenters position the components on temporary cribbing to simulate real-world elevation and loads. Using mallets and careful alignment, the team tests all joints, particularly the curved braces and king post intersections, to ensure tight flush fits. This pre-assembly allows fine adjustments before transport or raising, verifying tenon depth, shoulder contact, and aesthetic continuity. The arched braces require special attention due to compound angles and stress distribution. Any mismatch at this stage is corrected by hand planing or adjusting the mortises. The fit-up ensures structural reliability and visual integrity before final pegging and installation on site. Accent Truss specializes in crafting heavy timber trusses for Gerald Associates homes, including the iconic Lodge Room Truss. In the Anderson, South Carolina shop, the process begins with cutting and labeling timber pieces for a specific project, such as the Nana Halo design for a home in Australia. Using detailed shop and assembly drawings, each timber piece is matched with corresponding labels to ensure proper placement. Assembly starts by spreading the truss components on sawhorses, ensuring access to both sides for proper alignment. The rafters and king post are loosely fitted first, gradually joining halves together. Due to the complexity of mortise and tenon joinery, adjustments are made to ensure a precise fit. Once assembled, screws and a ratchet strap secure the truss, followed by checking measurements. After drilling tenons and completing finishing touches, the truss is ready for shipment. This meticulous process ensures high-quality trusses for various custom homes worldwide. The construction of a handcrafted timber frame hexagon gazebo, 16 × 16 feet, begins with site preparation and careful planning. The gazebo features a 16 feet x 16 feet footprint with 2 feet overhangs, supported by strong 6x6 posts and framed with 6x8 beams for both stability and aesthetic appeal. The first step is to clear and level the site, marking the positions for the 6 posts that will serve as the foundation of the structure. Next, the timber is cut according to the provided detailed plans, which include a complete timber list formatted for easy reading and large print. The components, including the 6x6 posts and 6x8 beams, are pre-measured to the correct dimensions, which streamlines the construction process. Traditional joinery techniques, such as mortise and tenon joints, are used to assemble the frame. The beams are attached to the posts, forming the hexagonal shape of the gazebo. After the frame is assembled, the roof structure is installed using additional beams and rafters. The 2-foot overhangs are secured, completing the gazebo's characteristic look and providing protection from the elements. Finally, finishing touches are applied, including sanding the timber, treating it for weather resistance, and sealing the joints for long-lasting durability. The detailed plans guide every step of the process, ensuring that the result is a sturdy, attractive gazebo perfect for outdoor spaces. By following the clear instructions, you can create a beautifully crafted timber frame structure that will last for years. A timber frame mortise and tenon truss with spline detail begins with selecting high-quality hardwood, such as oak or Douglas fir, for its strength and durability. The wood is carefully inspected for grain patterns and defects to ensure stability. The process starts by cutting the tenon joint at the end of the horizontal timbers. The tenon is a projection that fits precisely into a corresponding mortise hole in the vertical timber or truss components, ensuring a secure connection. The mortise is carefully formed in the vertical timber using chisel work, aligning perfectly with the tenon. Precision is key to ensure a tight, snug fit. A spline, a thin piece of wood, is then inserted into a groove cut along the joints of the timbers. This spline provides additional lateral stability and enhances the visual appeal of the joint. The frame members are assembled in a dry fit process to check the alignment of all joints. Adjustments may be made to achieve a perfect fit. Once everything fits correctly, the pieces are permanently joined using traditional timber frame techniques, often with wooden pegs or metal fasteners, depending on the project's requirements. This method results in a durable, well-crafted truss system that improves the structure's strength and longevity, making it suitable for both modern and traditional timber frame construction. The timber frame truss spline detail uses a thin spline inserted into a groove, enhancing joint stability, strength, and aesthetics. It reinforces connections, ensuring long-lasting durability in both traditional and modern constructions.